you, Hans. Yes, it is my pleasure to be here with you from Geneva, and I'd like to welcome you and say good morning or good evening for some of you who are far away east. As you know, the title of my presentation is Energy Efficiency, a Profit Center for Companies. And this presentation will be devoted to discuss a broader perspective on energy efficiency by considering energy efficiency investments as a source of profit for companies. In a second step, I will also introduce and discuss Task 26, Multiple Benefits of Energy Efficiency, a joint project of two technology collaboration programs of IEA, demand-side management and industrial energy-related technologies and systems, IETS. I think first it's useful to briefly introduce myself, since my professional life is also strongly influencing my approach and the presentation of today. I have a PhD in business management and an MBA as well. I'm working as a researcher with two universities, University of Geneva and of Neuchâtel. I'm also teaching investment decision making, and I'm a co-director of the Certificate of Advanced Studies in Energy Management. And besides that, I'm working as a consultant, and as a consultant, I'm collaborating for now 10 years with several local energy authorities on audit programs. So I consider myself as a mix of an academic person and a practitioner. And I'm very often in contact and collaborating with engineers. The plan of the presentation will be as follows. First, I would like to introduce the context of the subject, and then the core of the presentation, energy efficiency, a profit center for companies. It will be divided in three parts. First, the concept of this idea of a profit center, then some examples, and finally a toolbox. Then I will switch to the second part of the presentation. Then I will describe to you Task 26, Multiple Benefits of Energy Efficiency, before a short conclusion. The context of my work and of this presentation on energy efficiency as a profit center. The first context is a very well-known problem, and this problem is the so-called energy efficiency gap. We know that there's a huge energy efficiency potential which remains untapped everywhere, and as you can see in this slide by the IEA, in the business as usual scenario, 2/3 of the economic potential to improve energy efficiency will remain untapped in the next 20 years. The second context of my presentation and of my work is investment decision making. This is really my core research theme, and the main research finding is regarding this subject is that financial logic is not decisive, and strategic logic is more important in business investment choices. But also there's a huge diversity which is observed between company situations and behaviors, even within the same industry. Anyway, strategic logic is more important than financial logic in investment choices by businesses. What does this mean? A common definition widely accepted of strategy is that it is a balance between internal resources and external factors in order to build a durable, competitive advantage through resources allocation. And the diagram at the left part of the slide illustrates this definition. So with this definition of strategy, we can then say that an investment will be strategic for a company if it contributes to to create, maintain, or develop a sustainable competitive advantage. So when saying that strategic logic is more important than financial logic, it means that we will have to show, to illustrate, to demonstrate the contribution of an investment to the strategic position, the competitive advantage of a company, in order to help decision regarding this investment. This also means that the classical engineering technico-economic approach, which consists in analyzing energy savings, in translating these savings into financial savings, and finally, if the profitability of the investment is acceptable, then there would be an investment decision making. This is a logic chain of decision events for the technico-economic approach, but unfortunately this approach does not work or does not work well enough, so we need to find other ways. The third context of my presentation is regarding the non-energy benefits of energy efficiency. I propose here a definition. Non-energy benefits of energy efficiency are all the benefits entailed by an energy performance action which are not specifically energy benefits, meaning energy savings translated into monetary savings, in and of themselves. We can speak about non-energy benefits, but you will find also multiple benefits, ancillary benefits, or secondary benefits. We can also speak about impact. This work is related to a very important report by the International Energy Agency, which was presented in September 2014 on capturing the multiple benefits of energy efficiency. Now let's start the second part of this presentation, and I will start by describing here the concept of how can we consider energy efficiency projects as contributing to companies' profits. The first question which we can raise is, what is profit? How can we achieve profit? And I'm sure that you would easily answer that there are two paths to reach or to increase profit in a company. The first one is to increase turnover, and the second one would be to reduce cost. But of course, it is better to still remember about risks, because it's no use to increase turnover or to decrease costs when you put your company at risk. So to decrease costs is pretty easily to identify, but how would you increase sales? This is a more tricky question. And in order to answer that question, we can just very slightly change the presentation of this profit ways. And here, instead of speaking about turnover, we speak about value proposition. And so if we have a high value proposition, we will increase value for customers, and they will be more keen to buy our products, so we will increase turnover. But of course, we will bear costs to create this value proposition and risk to create this value proposition. These are actually the three dimensions of competitive advantage, and by evaluating contribution of an investment to these three dimensions, we can evaluate what I propose to call strategicity of these investments as compared to profitability of these investments. Value proposition is a very important concept, and it's important in competitive advantage. It's not an easy concept, but because value is not the financial value, it's not the sentimental value. It's more marketing value in the sense as it is a set of benefits that product or service promises to deliver. And you can, I believe, easily understand here how you have two very different cars proposing different sets of benefits to different segments of customers. For many companies, strategic advantage is based on a superior value stemming from providing unique benefits and not for offering lower prices. I think this is very important because in the energy field, we are very often, I would say, obsessed by the idea of decreasing costs in companies, and mainly and especially energy costs. But we need to remember here, as emphasized by Michael Porter, who is a kind of a guru in the field of business management. Not kind of, he's a guru, definitely. And as he said, value instead of cost must be used to access competitive position, since firms often deliberately raise their cost in order to command a premium price via differentiation. As I mentioned in my introduction, I'm collaborating with Canton de Vaud on a program on energy audits for large-scale consumers, large-scale energy consumers, and I've categorized companies on a value-cost scale to understand the main source of their competitive advantage. I've just taken a sample of 20 Swiss companies participating to this audit program. And so you see that actually 14 of these 20 companies base their competitive advantage on value proposition. And only 4 companies out of these 20 base their competitive advantage on cost. So they propose products at a low cost. And 2 of them are basing the competitive advantage on a mix of value, proposition, and cost. So this is just to illustrate and to confirm this important statement by Michael Porter that value is really important in competitive advantage. Examples of positive characteristics or benefits of use for customers attached to companies' value proposition are, for instance, it's not exhaustive, but we could mention very important like quality, purity, reliability, precision, versatility, efficiency, design, innovation, diversity, availability, service, technical support, and last but not least, prestige. And as I said, for many companies, value proposition is the main source of their competitive advantage and thus of their sales. Now the question is, okay, what's in it for us? What's in it for energy people? It is important because then it means that we need to try to figure out how we can contribute to companies' value proposition with our energy efficiency projects. And actually, as we will see, energy services are often key to guarantee the value proposition. Now I will go through some examples to illustrate how energy efficiency investments can contribute to competitive advantage of businesses. I've selected 4 examples, and the first, I tried to take examples in different sectors of activity. One is tertiary sector, it's a hotel, but I think it's also interesting to see what happens in municipalities and communities. Then I've picked up an example in the building to show the perspective for a real estate investor. And finally, industrial example in the beverage industry. So the first example regards a 4.5-star hotel, and it's related to window replacement. The current situation and its weaknesses it is that the single window glazing no longer meets the new legal standards. Half of the rooms are overheated by the sun in the afternoon. The traffic noise is a real bother. So the energy efficiency action would be to replace existing windows with double glazed windows. So, yes, okay, this is the mainstream usual energy efficiency analysis, to look for energy savings and to look how to reduce energy costs. So you see it's a very restrictive approach on the energy efficiency investment. But I can really guarantee you that it's a very, or probably you've seen that in your professional life as well, but this is normally the approach adopted by engineers in their project. But you will see that we have many other benefits related to this window replacement. First, we will have an improved product quality. What is product quality in the case of a hotel? It's improved room comfort. This will produce enhanced image and brand, and the brand will be stronger. This will increase product attractiveness. Customer loyalty will go up. Then you will have a reduced commercial risk. You will also have other cost reductions, such as CO2, and you will have reduced CO2 risks for what could happen in the future. So you have a reduction in cost, you have a reduction in risks, and you have definitely a significant contribution to the value proposition. The second example is related to, it's a municipality example, and it's related to the improvement of a sewage pumping station performance. And I've taken this example from a paper from Pye and McKane. The description of the current situation and its weaknesses. There are, okay, maybe I will not read everything, but there are two pumps handling a lot of raw sewage per day. One pump handled the entire peak flow, and the second pump kicked in only in extreme conditions. But the system experiences frequent breakdowns, and there's occasional flooding and sewage spills, which is really extremely unpleasant and can entail problems with the neighborhood. And so the energy efficiency action is regards installing a smaller pump with direct online motor, and this new pump handles the same volume and it runs for longer periods of time. And so the old pumps handle infrequent peak flows only. Let's have a look now at the value, cost, and risk analysis. Okay, so again, this is the common energy efficiency engineering approach. Lower energy costs, yes, we have lower energy costs in that case, and they are pretty important. We have also lower maintenance costs and longer equipment lifetime, so contribution to cost reduction is really interesting. We also increase the pumping capacity by 25%, so we will have less investment spending in the future. This explains why the payback period comes from 4.6 years to 1.9. But we have also much less risks because we have lower flooding risk, lower breakdown risk, lower legal risk, all very important aspects for the municipality. And regarding the value, we have a better service quality, less noise for the residents. We have a better service reliability, a better image, and finally, higher customer and employee loyalty. So there's also a significant contribution of this investment to increasing the value proposition of the municipality to the administrators, to its clients in a way. The third example regards commercial building. It's a commercial buildings where boilers are replaced. The current situation and its weaknesses. The two current boilers in the basement are oversized and outdated. Maintenance costs are high. So the energy efficiency action consists in installing one new, more energy efficient boiler, which is sized according to real needs, and so it frees space. And then two additional parking places are created in the space saved. The storage rooms for bicycles is also enlarged, which is very nice advantage, nice benefit. And okay, we still have the common lower energy costs, but also lower maintenance costs, lower CO2 costs. On the risk side, we have a lower breakdown risk because the boiler is newer. We have a lower CO2 risk. We have a lower brown risk, which is this is an interesting concept. It's the risk of not doing something. If the situation changes in the future, we may face difficulties. But we have higher product quality and higher product reliability. In this case, it means the comfort in the building, and the reliability is related to the fact that we don't have any more breakdown risk. We have a stronger image and branding. We have then a higher product, a higher building attractiveness, a higher customer loyalty, and this contributes to the value proposition. What is interesting is that a higher value proposition translates into lower vacancy risk, occupancy rate goes up, and leasing income is up as well. And we also have additional income through the additional parking places which are rent. All this will translate in something very important for real estate investors. The capitalization rate will go up. The last example is it's an industrial example. It's in the beverage industry, the replacement of a filling line. And I would like to say hello and thanks to Marina Santoro. I think she's listening to me, and also Samuel Gerber and all the team in Lucerne University of Applied Sciences and Arts, because Marina and Samuel and the team gave me this example and the figures. And I also would like to thank the Swiss company which accepted for this case to be described here. I cannot mention the name, but it's a real case. And as you will see, it's very interesting. So, description of the current situation and its weaknesses. Bottle filling line is for multiple types of bottles and beverages. And this can't meet production requirements over the whole year and must be compensated with overtime on Sunday. And the system is outdated. So the energy efficiency action consists in installing a new filling line with faster filling speeds, reduced working hours for the staff, for the same productivity, and also it translates in reducing cleaning needs and reduced water and energy consumption. Again, we will go through, I think now you are familiar with this analysis of the value, the contribution to value cost risk of an investment project. And yes, of course, lower energy and CO2 cost, lower CO2 risk, lower breakdown risk, because again, the equipment is new. This translates into maintenance costs down by 45%. You have lower accident risk. You don't risk to lose some production batches. And this translates into lower commercial risk and lower legal risk. Then also it translates into the rejection rate decreasing and also reduced water needs reduce chemical and staff costs go down as we see because of this new equipment. On the value proposition side, what happens? Yes, we have a higher product quality and a higher product reliability. This is very often the case in industrial energy efficiency projects. And in this investment, it doesn't translate into an increased income, but in many other examples, it translates into additional sales. We have other contributions to the value proposition, a stronger image and branding, higher employees and customers' loyalty, and all this translates into higher product attractiveness. We've evaluated this project financial attractiveness. The first slide here shows only the energy cost reductions. And okay, you have all the figures. These are real figures on which this Swiss company has based the decision. As you see, it's not very attractive in financial terms because the net present value is heavily negative and the internal rate of return is negative as well, and the simple payback time is greater than 25 years. But this picture changes if we include multiple benefits into the financial analysis. And here I will use this arrow here. You see that we have the financial savings coming from the energy savings. We have electricity consumption decreasing, natural gas consumption decreasing, but we have also included other cost reductions, maintenance, material, staff, reduction of product losses, and reduction of special equipment. And all these cost reductions translate in the final free cash flows. And you will see that this is extremely important because actually it completely changes the financial figures. The net present value is now highly positive with 8.2 million Swiss francs. The internal rate of return is pretty attractive, above 20%, and the simple payback time is now of 4.6 years. So you see, this is pretty interesting. Okay, I've shown you the concept, I've shown you some examples, but now I would like to go a little bit deeper in how we could which kind of tools could be applied to implement this approach in energy efficiency investment projects. I will go through a little bit quickly into this part of my presentation because I'd like to also have time to present the task 26. Here you see, okay, how can we identify activities of a company, the important activities, and how we can contribute to these activities with energy efficiency investment projects. The first tool, analytical tool, is the concept of the value chain. And this concept is applicable at a whole company, but this level of analysis is too general. So maybe we could use another concept at the operations level, and this is process mapping. Process mapping is a concept very common in industrial companies or in any companies, and it's related to a very popular management approach now, and it is lean management. As you see, you have different process activities, and they serve a process customer. They can be feedback and so on, but this is interesting to really represent an industrial process. It can also be useful to represent actually a commercial process, because you can represent any type of activity with this kind of tool. I've used this process mapping to represent the aluminium foil production process. You see that you have five process steps: casting, pressure furnace, hot mill, cold mill, and thermal treatment. I think it's useful to quote here that a sentence by Mr. Germanier. He is the energy and project manager of Novelis. Novelis is the first world producer of aluminum foil, and this is used in the car industry. So Mr. Germanier said, safety is always a priority issue. Secondly, product quality, reliability, and energy are the important criteria. So you see, energy here, because it's aluminium, is an important subject because the aluminium foil industry is consuming massive amounts of energy. But still, it's in the fourth position, and I think it has to be mentioned. So anyway, we have here this foil production process map. What would be the engineering approach on such a process? It would be to look at the equipment and to look at how the consumption, energy consumption of these equipments could be reduced. So the classic engineering approach would focus on reducing consumption of the carriers, the energy carriers we see here. I suggest to enlarge the approach and to focus on energy services. And you see you have important energy services which are listed here, and these energy services are really important for all the process steps which are again listed here. So I think for every industrial process we can develop this type of analysis by looking at the energy services which are very often absolutely key for the process. You see that here it's another way it's a way to mix these two analyses: the process mapping, the process map with the different steps, and the energy services associated to this process mapping. And actually, energy services, as I just mentioned, are absolutely key in contributing to this process, because very often you have critical values which are very strict in terms of heat or cold or lighting level or ventilation, humidity level. All these is really critical for process quality and sometimes for process quantity. These are examples of key energy services and the related constraints in industrial operations. I could give many other examples. I've picked up those from the energy audits in Switzerland. You see here in the manufacturing of blades for the paper industry, there's a strategic risk of temperature drift in warehouses and production area, production of motion sensors for aeronautics, importance of strict climatic conditions in production areas. In an industrial bakery, the cooling unit production influences product quality, the cold chain stability and reliability, and the time between processes, water cooler and fermentation chamber. Again, I could give many other examples. As a matter, actually, these energy services are key for the processes, but they are not really controlled, because production people, they are not fully aware of how it is important. So to summarize, I suggest to base an analysis to demonstrate strategic value of energy efficiency investment through a three-level analysis. The first one is an operational analysis. In order to assess the contribution of an energy efficiency project to a company process, the following elements have to be analyzed: security, products, which can be goods or services in terms of quantity or quality, energy services, which are normally not analyzed in industrial processes by the production people: time, flexibility, consumable, and waste and emissions. So it means, as you see, a much broader perspective, and it means also to collaborate with production. It means a collaboration between energy people and production people. The second analysis would be the financial analysis, and I would like to say here that to strongly emphasize actually that the benefits or impacts of energy efficiency projects are quantifiable. You have three methods, well-known methods to define magnitude: estimation, calculation, or measure. And of course, you cannot always find these figures yourself, but information does exist in companies. You just have to ask the right people. And there's also a way to connect with these people and with the financial departments and all that. The third level of analysis is a strategic analysis. And here it enhances how investments, energy efficiency investment, contribute to stronger competitiveness and higher profitability in businesses. How come? Let's see. As I illustrate through the four examples, they contribute to increasing value proposition. They decrease the cost to produce these value proposition, and they decrease risks as well. And decreased risk will contribute to lower costs, to lowering costs, and to increasing value proposition. And better value proposition will translate into a higher quantity sold and or in a higher unitary price. So this means higher turnover. And higher turnover and lower cost will translate into higher profit. So this refers actually to the title of the presentation, that I hope that I've demonstrated that these energy efficiency projects really contribute to a higher profit of many companies. So now I come to the last part of my presentation, and it is regarding task 26, multiple benefits of energy efficiency. And this is a joint project between two technology collaboration programs by IEA. The first one is IEA DSM, and the other one is IEA IETS. Why task 26? I've gone through the first part of my presentation to illustrate that energy efficiency projects translate into higher value, lower cost, and lower risk for companies. And this has been actually demonstrated by research for the last 20 years. I've just mentioned here about 50 researchers in Europe, in the United States. You see here in Europe. I have to also apologize for all those I've forgotten. I remember about Katie Gender in Great Britain, people of Combi Project in Germany. What else? Sam Jenkins at the Department of Energy and Climate Change in Great Britain. In the United States, there are many people as well with consulting companies, with ACEEE, with the Department of the U.S. Department of Energy. All these people for 20 years speak, research, and show the advantages of energy efficiency projects. There are people elsewhere. I don't know them. I just take the opportunity also to say that many researchers will gather at the IEPEC conference in Amsterdam, you see here. So I think it's the last day to have a fair rate to register to this conference. So all the efforts by all these researchers didn't translate into these non-energy benefits making their way into companies. And this is demonstrated by a in-course project. It's a MKey research project. MKey is management as a key driver of energy performance is a research project which is part of the National Research Program Managing Energy Consumption of the Swiss National Science Foundation. You can find more information there. According to MKey Research Project, out of 140 answers to our survey, 55% of companies rarely or never include non-energy benefits in their investment calculations. You have the precise figures here, but I think it's really important to remember that 55% of companies never include non-energy benefits in their investment calculation. And actually, why is that situation? My explanation is that there are two different and parallel business cultures and interests. On the one side, you have production people who care about product quality and reliability, safety of process and facilities, flexibility, production time, more moderately about environmental impact of their production, and very moderately, except in some high energy intensive industries, they very moderately care about energy costs. And then you have another business culture and another kind of professional world, and this is the energy people, engineers, inside or outside companies, and they are framing energy efficiency projects. And actually, what do they care about? They care about energy consumption of facilities and equipment. And so you see, this is not matching, actually. So this is also, I believe, why energy is considered as a non-core business issue. It's non-strategic and it's secondary for many companies. Energy management people are often relegated, I would say, in a way, in a corner of company, and they don't have access to top management, finance management, and production. Then why task 26? Because the non-energy benefits of energy efficiency have to be analyzed ex ante, meaning before the project starts, at project level with convenient analytical tool. These benefits have to be better documented and quantified and communicated in a convincing way to stakeholders. Why task 26? A third slide on that. It's because we need to bring concrete and applicable solutions to several important needs. A need to enlarge the usual technical approach applied to energy efficiency projects, a need to propose training to engineers working on energy efficiency projects, some guidance, and to supply them with multiple benefits data, a need to attract businesses' attention to the decisive contribution of energy services to the core business, and finally, an important need to bridge energy and climate communities. So in order to all these why, then I would suggest this what. So what is the content of this project? There are four main deliverables. Toolbox consumption. The first deliverable is conceiving a toolbox, meaning to conceive an analytical tool which could be based on what I've shown you earlier in my presentation, and this analytical tool could be used ex ante to better identifying and assessing the multiple benefits related to energy efficiency projects. The second deliverable of task 26 will be a toolbox delivery. So we would conceive and realize templates which will be used in workshops in the participating countries, and we will also make a marketing and communication campaign on multiple benefits of energy efficiency. Then we will develop a learning base, which is very important because it will contain data on multiple benefits organized by business activity and municipality type, energy efficiency measure type, and geographical location. And finally, the fourth deliverable will be on dissemination with one-day, what we label toolbox training sessions and webinars and online courses organized. I think it's also important to locate our task 26. You see that you have two axes to analyze multiple benefits of energy efficiency, the supply side, demand side axis, and then the macroeconomics or social level, and microeconomics or individual level of energy efficiency project. Actually, the IEA work until now was mainly focusing on macroeconomics aspects, and we would like to focus on the industrial companies, commercial companies, so all businesses, and on municipalities. And so we are very deeply focusing on project level, because I think this is where you can find real examples and precise data. So when this will be, the task 26 will start next month and will last for 3 years. There will be 4 expert workshops. In conclusion, I would like to say that we need to integrate the multiple benefits of energy efficiency in a multi-level and comprehensive analysis to raise the strategic and financial attractiveness of energy efficiency investment projects. Actually, strategic analysis encompasses financial analysis, but the contrary is not true. So this is why a strategic analysis has to be first in this multi-level approach. But it's also including the operational analysis with the contribution of energy services to process. Finally, I would like to say that we most welcome new collaborations and partners, and please feel free to contact me or Maya Dahlgren, who is the co-project leader, and I also say hello Maya. She's from the Swedish Energy Agency, and if you would like to have information regarding this project, please contact us. And with that, I'd like to thank you for your attention.